Voyager 1 is the most distant human-made object ever, as one of a pair of spacecraft launched towards the edge of the solar system, 44 years ago. Its journey has taken it right to the edge and beyond it, and it is now fying through the interstellar medium, beyond our own sun's influence. Instruments on board the spacecraft that attempt to analyze that interstellar medium have heard a constant drone, which appears to be the noise of the universe beyond our own neighborhood. The drone appears to be emitted by interstellar gas or plasma waves that are out in the largely empty space between the stars. It's very faint and monotone, because it is in a narrow frequency bandwidth, said Stella Koch Ocker, a Cornell doctoral student in astronomy, who found the emission. We're detecting the faint, persistent hum of interstellar gas. The findings suggest there is more going on in interstellar gas than scientists had previously thought. Scientists are not sure what low-level activity could be causing the noise, but suggest it might be the result of thermally excited plasma oscillations. Researchers hope to use the drone to understand how the interstellar medium interacts with the border of the solar system, and how that border, known as the heliopause, is shaped by the wider interstellar environment. When the Voyager 1 spacecraft went beyond that heliopause, it picked up perturbations in the gas that sits in interstellar space that were caused by our Sun and could be seen in the information it sends back to Earth. But between them there was a constant, background hum. The interstellar medium is like a quiet or gentle rain, said senior author James Cordes, the George Feldstein Professor of Astronomy. In the case of a solar outburst, it's like detecting a lightning burst in a thunderstorm and then it's back to a gentle rain. Though Voyager 1 is now spectacularly distant from us, it is 14 billion miles from Earth, and getting further all the time, it can only send back limited amounts of information. Researchers receive about 160 bits each second from the spacecraft, much less than the in itself now relatively limited 21 kilobits it could deliver when it first set off. That data is transmitted to Earth through the Deep Space Network, a set of facilities that are dotted around the world and gather information from spacecraft from elsewhere in the solar system, and beyond. Voyager is expected to carry on analyzing that interstellar medium for the next few years, and researchers hope that some of that work will allow them to keep tracking the density of the space beyond our solar system. In the newly published paper, researchers also suggest that future interstellar missions could give further detail on that plasma hum. A deep analysis of this hum will help us better understand the interaction between the interstellar medium and the solar wind. Earlier, Voyager 2 had reported an increase in electron density just on the other side of the heliopause. So knowing the pattern of how the density is changing can also help figure out the reason behind it. But on the darker side, our farthest spacecraft is running out of power. Its power source may not be able to keep the instruments operating after 2025. Still, this detection has raised a hope that even in a few of its remaining years, Voyager 1 is bound to surprise us with its capabilities by exploring the deep corners of the unknown space.